How was the periodic table first organized? Have you ever wondered how scientists first arranged the elements we see in the periodic table? This fascinating journey began with Dmitri Mendeleev, a Russian chemist, in the year 1869. Mendeleev took the known 63 chemical elements and arranged them based on their increasing atomic weight, which we now refer to as atomic mass. As he worked, Mendeleev made a remarkable observation. He noticed that elements with similar chemical properties appeared at regular intervals. This pattern allowed him to group elements into vertical columns, which we now call groups or families. Each group shares similar chemical characteristics, making it easier to understand their behavior. Before Mendeleev's work, other scientists had tried to classify elements. For instance, Johann Wolfgang Döbereiner identified groups of 3 elements with similar properties, known as triads, in the early 1800s. Étienne François Geoffroy created an affinity table in 1718, grouping substances by their chemical affinities. John Newlands proposed the law of octaves, noting that every 8th element shared similar properties, but his ideas did not gain much acceptance. What set Mendeleev apart was his innovative approach. He not only organized elements by atomic weight but also considered their chemical properties. This combination revealed periodic trends and relationships among the elements. Mendeleev used note cards to representing each element's properties, arranging them like pieces of a puzzle until a clear pattern emerged. This organization was a major milestone in science. It provided a systematic framework for understanding elements and their interactions. Mendeleev even left gaps in his table for elements that had not yet been discovered. He predicted the existence and properties of elements like germanium, gallium, and scandium, showcasing the power of his method. The periodic table reflects fundamental principles of matter and energy. It shows how elemental properties repeat periodically when arranged by atomic weight. This innovation laid the groundwork for modern chemistry. It enabled scientists to predict how elements would behave, discover new elements, and develop new materials and technologies. Over time, scientists refined Mendeleev's work. They replaced atomic weight with atomic number, which is the number of protons in an atom's nucleus, as the organizing principle. This change resolved inconsistencies in Mendeleev's original table. Today, the modern periodic table remains a central tool in science, education, and industry, marking a key historical milestone in our understanding of the natural world.